So hello everyone, my name is Chris Murphy. I am a senior technical artist as part of the DevRel team at Epic Games. I've been to a couple of Unreal Fests in the past, so there's a few people that have come up and said hi. Others have caught some of my similar kind of talks floating around, and that's nice too. Today we're going to be looking at the unfeatured features of Unreal, which really what this is kind of a highlight reel of features and tips that developers often don't know about. I really wanted to look at some of the stuff that is in the engine that I'm just not seeing as much use as I would expect. And I think a lot of these things are kind of buried away in CVARs. I think a lot of these things are buried away as it's Unreal, right? We always have that, like, there's a checkbox for something, but you never knew that checkbox existed, so you went and engineered your entire solution. So let's look at a few different things. I want to start off with scene construction to begin with. And specifically, I wanted to call out the environment light mixer, which I just went to Window Environment Light Mixer. I bring it up because when you launch that thing up, it gives you a bunch of different controls that you can pretty much mash left click on to auto-create all of the default lighting of a scene. So Window, M's Light Mixer, I can hit skylight, atmosphere, clouds, fog, and directional light, and it kind of adds all of them into the scene immediately. I say this because every time I'm doing a new quick test map, this is me getting a nice-ish light environment in about 7 seconds, you know what I mean? So it's a really, really good first step, and you can just get up and running and going really quickly on a new environment. This is me. I've sped this up to 2 times speed, but we have a feature called CubeGrid. CubeGrid's tucked away inside the modeling tools, but it essentially lets you to do really quick rapid prototyping for environments, really, really quick blockouts. You use Q and E on CubeGrid to kind of shift a grid that you've drawn. When you're holding control, you can also just drag a surface up and down. And of course, the second you hit apply, it'll just work with Lumen or whatever else. Another interesting quirk of CubeGrid is it really works on anything you've got. So if you have a mesh in the scene that you want to carve a big like Boolean extraction into it, you can use that as well. So if you have something in there, you can kind of use CubeGrid to kind of cut it away and create a little environment inside of a cliff face or something like that. Draw Spline tool is a tool that is in the modeling tools, and I can understand why some folks wouldn't expect it to be there. But I imagine most devs in the room have used spline tools in Unreal before, right? Like we've all used them at some point. You've created a blueprint that adds pipes, a blueprint that adds roads, whatever. I bring this tool up because what it actually does is it creates a blueprint and it overrides the spline component. And what's really useful about that is that when you bring it in, it essentially turns any of your existing spline tools into tools. So you can just set up a preset that says paint pipes, and when I open up the spline tool, it now just allows me to draw into the scene with like a nice little friendly painty way, instead of like manually clicking on those and dragging them around to set it up in a quick way, but still somewhat painstaking. This is a really good one. So Landmass erosion came in with 5.4, and we have like a nice, I've made, not nice, it's pretty ugly. I put together like a quick environment, right? We've all done this in landscape, and we get this far before we're like, all right, at some point I'm going to spend a whole bunch of time making this look prettier. The cool thing is Landmass erosion lets you actually go ahead and click simulate erosion. And when you click that and you give it a second, it'll process it. There you go. And give you what I think is a much nicer looking environment. It gives you a little timeline. I think this was Ryan Brux's handiwork, but it snuck in 5.4. And it allows you to like set up the weight maps that you want it to be painting to. You can add like smooth steps. You can add additional like erosion steps to it, noise filters, etc., etc. It's pretty cool. And honestly, it really does just get a quick environment that you've thrown together into something that looks quite nice. It comes together really quickly. The other thing that's worth noting on the landmass erosion front is it sits on top of, it sits in a specific layer of your landscape stack. And because it sits inside of a specific layer, it means that you can still draw on top of this to add roads or whatever else you need, which gives you a really great result. So RVTs, if you've known me long enough, you'll know me as a somewhat RVT evangelist. I really push this feature. But runtime virtual textures are essentially a way for us to do an orthographic view of the world. Like imagine a top-down view of the world where we actually, the first time we ever look at a pixel, we save its result. And then anything else can look at that information and say, hey, what is the pixel directly beneath me? And the reason that's really useful is that it means that when you put a mesh inside the world, I'm just going to loop that video for you all. It means when you have something inside the world, it can actually access what the ground looks like beneath it. And when it can access what the ground looks like beneath it, it can then do a smooth blend. And that's not just a smooth blend of the color. You're actually able to blend the normal as well. Like see how as that rock hits the ground, you kind of can't see that seam that you would expect on the environment otherwise. This is something that, again, it wasn't really in our initial docs. I've brought it up in quite a lot of talks, but it wasn't really like showcased inside of our patch notes in the way that I wanted them to. This is a little trickier to see up here, but there is a nice little node that we have called texture variation node. Normally, when you just plug UVs into something, you get that top result. Texture variation is a UV-based blend that gives you just kind of a slightly more chaotic look so that you don't get as much texture tiling. I use it a lot. Because it's on the UVs, it's actually really cheap, which I really, really like. This next one is, there we go. This next one's something that I see a lot. What happens is when you're creating an environment, most people set up their physical materials for their main objects. You know, like they set up the metal stand that they've imported has a physical material saying it's metal. But for the landscapes, they skip it. And that physical material output node that I just had on screen actually lets you say, hey, this part of the landscape based on these pixel colors represents this kind of material. And this part of the landscape based on these pixel colors represents this part of the material. The obvious advantage here is it means that, you know, your footprints, your footsteps, your sparks, and everything else like that can all be like correctly set up for the environment you're making. So if you're painting in stone and dirt and grass, they can all behave differently. There's one of those things that I find in a lot of projects that ship is just, if you're, and I know I'm nitpicking when I say this, but like, you know, if you're shooting a gun or something like that, and your dirt starts acting as if it's stone, and then your grass acts as it's stone, and then the stone acts as if it's stone, it means that they probably have set up something like this. And it's really not that much extra work to get it going. I bring up this just quickly. The water system in Unreal gets a lot of use. But specifically, I wanted to flag that the defaults for the water system get housed inside of your project settings, which means that whenever you add a river or a lake or the ocean or anything like that to the world, the default information there isn't stored in the class. It's stored in the project settings. And I've noticed a lot of people that have been using the water system have been manually overriding each of their things one by one. But the system was set up to kind of have interop between each thing. And I think because of that, the options are kind of tucked away in a lesser known space. Now, this might be a little tricky to see, but in game, it hurts me. So on the top right is your standard default water output. Bottom right is what I think is nicer. What happens is, by default, we don't have virtual shadow map filtering enabled on single layer water. Turning it on is just these console commands, so making sure they're in your default engine under the render settings. It gives you a nice, smoother look to the shadows that are being cast on water. It's, you know, it's quite a few times I've gone in and I've seen a project that's very heavily water-based that doesn't have this on, and it's just like 2 lines to immediately massively boost the quality of the project. So this is actually a UE3 feature that wasn't in UE4, but it's back in UE5. If you go to Property View and then Control-click on anything, it will grab every other object in the scene that has that property and has that property at the same value. So in this situation, I can be like Control-click, physics turned off, and it will grab everything that has physics turned off in the scene and just highlight it for me. Okay? This is a really useful little feature that came back in 5.4, and you know, I think this is a really powerful thing. You know that situation where like one actor is acting up, and you're like, ugh, someone turned this on, that property that I thought no one would ever enable. This is useful because you can go control-click and be like, who else made this mistake? You can see them all. Render Resource Viewer, this came in 5.2. Render Resource Viewer literally just allows you to view everything that's currently using up your renderer resources. Quite often, people will increase their CVARs. They'll do things like upgrade the quality of something. They'll increase, their virtual runtime virtual texture sizes or something like that. But they don't really know the ramifications of that. The render resource view is a really accessible, easy way for you to be like, okay, what's actually going on with my VRAM right now? What's being used and where is it? And which buffers specifically are kind of eating into that? So it's not just like, hey, these are big textures. It's a lot more than the big textures. I can see everything else that's currently feeding into it. Local exposure came in, I think this came in with the Matrix Awakens demo. So it's a little tricky to see on these slides, but it's not a UE4 workflow, it's a UE5, like it's come in with UE5, but a lot of folks that migrated never updated their post processes. How it works is we basically do two passes on the exposure. You've got your low pass and your high pass. And we then blend those two things together. So you've got this mask that says, hey, this is the high exposure and this is the low exposure, and we blend them together, which allows you to get more detail in the darker areas, which doesn't come through so well on a high contrast projector. But let me paint you a picture. So if you've ever seen that situation where you've been inside of a house in a game with a really bright outdoor, and you look through that doorway, historically, you would either have nothing but bloom where that doorway is, and then you can see everything on the inside, or you would have a really visible exterior, and everything in the inside would be like super dark with no, you can't really see it. I can see one person here vigorously nodding. So local exposure is the ability for you to kind of blend those two things together and get a scene that has more detail across the board. So location volumes are another great feature that we've added. If anyone's using world partition here, you can add a little volume. And when you add that volume, you can just draw out where you want in the world this thing to be. I probably should have run this at 2 times speed. But when you get that volume, I can go ahead and save the map. So I'm going to name this area that we've just created Coolsville. Now, Coolsville over here, when you save the map, will now actually appear on your world partition map and allow you to say, hey, just load in Coolsville. And then I can unload Coolsville as well if I choose to. It gives you like a nice actual named marker to the things in the world. We find a lot of people just kind of memorizing where those spots are. This is actually the first part of an overall bookmarking system that we're looking at having. So I'm excited to see where these location volumes go in the future. But for the time being, I really just wanted to highlight that, if you are doing a large environment, being able to kind of denote these spaces ahead of time and just have familiar things, turn on the village, turn on the cave with the dragon, or whatever it's going to be, is a really useful workflow. That said, if you are turning things off and on again in world partition, just be aware of the pinning feature. Pinning is just, you can literally click on an actor and be like, please don't get rid of this no matter what I say to the streaming system. I want to keep this because I'm working on it. Custom filters. So for anyone that's unaware of it, you can type in regular expressions into the search bar on the content browser. But in this case, you can also do it and save that. So I typed in, find me everything with Nanite enabled is set to false, and a try count of more than 5,000. And we're going to call that sus meshes. And sus meshes will now automatically give me a little filter that gives me like a really quick way to validate the things inside the scene. Any of the information that's in the metadata there when you hold your cursor above an asset is something you can search. So I think you're getting older when you decide that one of the most exciting things to talk about is revision control. But I did actually want to highlight that the in-engine source control is becoming more and more important inside of UE. It has been a bit of a shift in terms of workflows for studios. A few things that I want to bring up, the first of which is uncontrolled change lists. Uncontrolled change lists allow you to set up change lists so that while you're working, you can be like, oh, those things that I just did, make sure that when I hit commit, they go up in a commit that is the lighting changes. And these bits go up in a commit that says the things that I moved around, or I changed this part of the pawn or something like that. But this really stops you from having that gargantuan commit situation where you're like, look, I'm going to just push up all 50 files that I just modified and have a giant commit log that someone out there is if there's anything wrong with it, they have to roll back all of those changes. Uncontrolled change lists gives you nice little bite-sized approaches. I want to flag that on the source control side of things, that diffing isn't just for blueprints. You can actually grab all sorts of things now and diff them and get more information in Engine, which is really useful. But also on that front, when you are doing diffing between things, just be aware of the step setup. Like, I wanted to bring this up because a lot of folks haven't been using the diff tools that we have in Engine, and as we're becoming more and more reliant on having good tools in the world for managing source control, you need to get familiar with some of these things. And so being able to step through and see what those changes were between the two blueprints that got pushed up is important. If you're going to be doing that, make sure you're using the lock and unlock functionality. Lock and unlock literally just says, hey, when I'm looking around, make sure the two cameras are at the same point so that we can see the differences in the blueprints that we're quickly checking out. Importantly, though, and this is tied largely to, I think this is Perforce only at the moment, there is a review tool, and the review tool actually lets you say review change list. So when we go here, I can do a search for a change list. I can load up that change list, and then I can actually see what things were in that change list and then launch the diff tool for those specific changes. And that, again, within Engine, you can also compare it against previous revisions, against head revision, or against what you're about to have conflicts with. So really, really valuable. It gets you out of trouble quite often. It was a little tucked away. For one other thing I wanted to bring up is just generally trying to make these things not problems by making sure they're fixed before they ever end up on the repository, right? So I wanted to just quickly bring up custom validation. Custom validation, you can set up your own data validation plugin. Like, you can enable it and have data validation rule sets. So data validation rule sets allow you to basically say, hey, I want to have a hook so that whenever I go to commit this asset, Unreal will call a warning if this blueprint doesn't have this value set. Or Unreal will call out a warning if this is null, or if this is set to debug and should never be committed as debug. Whatever it may be, having that kind of stuff I think is really, really important. And it allows you to make sure that that never becomes everyone else's problem. A cool thing is you can set up them through C++ or Blueprint. So this is a reasonably flexible setup that you can do. Now, I wanted to go into working with Nanite, and I know having a discussion on unfeatured features where I'm like, have you heard of Nanite displacement? It seems like a joke for some people in the room, and that's totally fair. But I still wanted to bring it up, because the thing with Nanite displacement is that it is off by default. And because it's off by default, there's a lot of folks that they've heard about it, but I just want to make sure that everyone knows that there's just two CVARs to enable it before you can start kind of tinkering with it. So it's not going to be something that's directly in front of you. But on the displacement side of things, I mentioned that and didn't actually fill people in what it was before. For anyone that doesn't know what Nanite tessellation and displacement means, essentially what happens is when we get, I think that video is not playing anymore. When we get something that's running Nanite tessellation, it breaks it out into just millions of tiny tries, right? Even if this was a reasonably low poly mesh, it heavily triangulates it on a per pixel basis. And then what happens is we can move any of those pixels up and down any given distance, which means that when we read in a height map, we get a much, much prettier asset with way more detail inside of it. Now, a while ago, we added Nanite landscapes. And Nanite landscapes is something you should make sure you're doing, because even though there wasn't a quality boost in the past with Nanite landscapes, what it did give you was a performance boost, because Nanite culls Nanite. And therefore, having a big block of Nanite, the landscape, meant that the culling was more effective. But Nanite displacement works on Nanite landscapes. So if your landscape material has Nanite displacement enabled, you get ridiculously high density environments where you can paint in mud, and as you paint in the mud, you can get these tiny little perfect crevices and bumps and everything else. I can't stress enough that it really raises the quality of your projects. And it's really, I think it's, for what it's giving you, it's reasonably cheap. And it allows you to actually have fewer meshes in the scene quite often, because previously what was going to be a bunch of rock and rubble meshes is now something that's painted into the world, and honestly often higher quality than some of the stuff you were going to drop in, because you can get nice fades between them all. In general, I want to make sure that folks are aware of the baking tools. So we have baking tools in the engine. It allows you to bake your curvature, your ambient occlusion, and things like that. I think position and normal are in there as well. But you can bake them to vert data or texture data. Now, Nanite meshes are super high poly. And because they're super high poly, you can bake in a lot of the detail that is currently often sitting inside of 2048 maps can just be brought into the mesh itself and massively reduce the amount of overhead you've got, okay? So if you're looking at what your material pipeline is going to be for assets, I'd strongly recommend looking at the baking tools in UE because they haven't really been like shown off aggressively, but being able to have curvature in every Nanite mesh means that you can start to do like procedural grime and moss and stuff like that as a part of your material, but without necessarily having to have that all as individual texture data, which can get quite large quite quickly. So we added spline meshes have been in a thing in Unreal for quite a while. We added Nanite spline support in 5.4. With that, we've had a lot of folks kind of jumping on Nanite splines, which allows you to just arbitrarily bend any mesh. I wanted to bring this up for two reasons. One is there is a thing called spline mesh actor, and when you add a spline mesh actor to the world, it's just got the spline controls on a single mesh by default. A lot of folks are still creating a custom blueprint for that one mesh, but that is something that's kind of a solved problem now. The other thing I wanted to bring up is that quite often when you're doing spline meshes on Nanite, you do run the risk of it suddenly getting a bit odd, especially if it's kind of lower poly. You end up with it like a single vert will blow out by a little bit, and you'll see it really quickly. But a lot of folks are like, I have no idea what this problem is. 0 out of 10, I'm switching engine. So, but no, seriously, like they look at it, they don't really know what it is. And I just wanted to flag that there is a little property that we've added called max edge length factor, which is a little tucked away. But if you're making sure that all of your Nanite splines are working nicely, often it's just a fact of you need to open up the mesh and kind of change that max edge length factor. On the topic of Nanite as well, I wanted to bring up preserve area. So you see that when we moved away just then, by default, all those leaves disappeared. When you enable preserve area on a Nanite mesh, even though these leaves are now smaller than one pixel on screen, it'll actually still keep them in. There's a little bit of extra cost here because we're not like as greedily getting rid of things, but it does solve this problem quite well. So I strongly recommend, if you've got foliage in Nanite, making sure that your foliage meshes have preserve area checked. The other one is world position offsets. We're seeing a lot of WPO with Nanite, and just because you can doesn't mean you should all the time. So when you have world position offset enabled, that still has cost to it. And the two big gotchas that one of the three big gotchas that we see in Nanite still is really, does your mesh have world position offset? And if it does have world position offset, what is that doing? So just making sure that you've set distances on your assets to say, hey, look, at 5,000 Unreal units, I want you to no longer render that waviness of the tree. It's an easy saving. Now, if you're trying to work out what's actually busted in your scene, be aware that we added a pixel programmable visualizer. There we go. Sorry, folks. It's 9 a.m. So the pixel programmable visualizer actually shows you any of the assets in the scene that have masked or WPO enabled right now. It's a really useful thing to just load up and be like, it's red. We should fix that. Or it's red. We should consider why it's red. So because it's called pixel programmable rather than show me Nanite, WPO, and masked assets, the pixel programmable pipeline is a more expensive pipeline that Nanite meshes with some of the bells and whistles need to go through. So I think quite a few people missed out on this visualizer because of just the name being the engineering name rather than the potentially more accessible, these are costly meshes name. Now, I mentioned masked. And I mentioned WPO. What I didn't mention was overdraw. So that was the third of the things that really stands out frequently on Nanite meshes. When you get really, really, really densely packed meshes that are Nanite, so if you get a whole bunch of things that are like stacked on top of each other, that's when you start seeing some performance degradation sometimes. So because of that, you really want to know what's going on with your scene about when those things are getting really close together. we added the Nanite overdraw view mode, which you should definitely turn on. Like, I don't know about you, I load that up, and it's great to have both a debugging mode that makes you feel like the predator at the same time. But you load this up, and you can kind of see that density. You get a bit of a heat map. You can see where you've potentially got too many things. Obviously, the trees stand out, but I can start to see down in this pathway down here that I may have too many rocks overlapping each other as well that are starting to become a point of concern. So Nanite overdraw, big win. The other one is VSM Nanite overdraw. So when your sun is projecting into the world, it's essentially kind of doing a draw pass, right? In the same way that the rest of your scene is, but it's doing it from the perspective of the sun. And it can also suffer overdraw. So, and this is an easy one to miss because we think about what we see, but we don't really think about the perspective of the sun from an optimization perspective, right? So having the VSM Nanite overdraw view mode, again, is very similar, but it's useful to load up, and sometimes you'll find, if you're finding that your VSM time, your virtual shadow map time is a little bit too high, this can sometimes be a culprit, and you can look down and be like, okay, this is what's going on. In general, for Nanite, I want to flag a couple of things just that have been added to make everyone's lives easier. In materials, you've got Nanite switch, so you can say, hey, do this when it's Nanite and do this when it's not Nanite. You've got the Nanite override material on static mesh components. So on a static mesh, you can explicitly say, if this is Nanite, just do an entirely different material that doesn't need this or this or this, because it's now super high dense, super high poly, right? And finally, there is another checkbox that's really useful to just make sure you're not going to break things, which is disallow Nanite. So if you've got like a volume that's always going to have translucency applied to it, just make sure disallow Nanite is set, and it won't throw in meshes that you didn't intend to. Now, when it comes to Nanite, one of the big things that we use frequently is assemblies. We've been using this a lot internally within various projects. You would have seen it in the Electric Dreams demo. So if you grab a bunch of assets and you right-click on them and hit level instance, that will now convert all of those assets into a single placeable actor. And the cool part of that is Control E in Unreal is edit. And if I click on that thing and hit Control E, it will open up a little editor that is just the sub level that we made. I wanted to bring this up because both it's very useful for Nanite purposes, because Nanite is really good at instancing stuff, right? And because it's really, really good at instancing stuff, the more you're able to get a bunch of smaller meshes and turn them into different assemblies in different configurations, the more you're able to take advantage of that performance. But the other reason is I see a lot of people doing things like procedural levels where they're making procedural rooms and they're sticking them all together for spaceships or whatever else. But I see them doing that in Blueprint, where they've essentially turned their Blueprint editor into a tiny little level editor. And don't do that. I'd strongly recommend using the level instances setup instead, because when you have the level instancing setup, you're able to actually have an editor to work with those things. Cool feature that we added that a lot of folks don't know about is we have added the level instance actor filters. So see here, I can turn the artificial meshes on and off in my scene. What happens is inside of my level instance, I can actually set up data layers, and that data layer, I can say this supports actor filters. And that means that any of the actor filters in the world now become layers that I can turn off and on that instance. So again, I can have like a tree, and then I can have the tree with, I don't know, a woodcutter has been to it and done there's a bunch of extra stuff in there. Like I can have, I don't know why that was my option. But I can have a bunch of different variants for my level instances, and I can drop them in and be like, I want this one, or I want this one, or I want this one, or I want this one. Which allows you to kind of more easily wrangle that content. And again, you don't need to set up a blueprint with a bunch of custom options that enables or disables this with a graph going with it, an array that you need to monitor, but rather you're doing it in the editor with the level editing tools that you're used to. And this came in reasonably recently, but there's a lot of folks that should be taking advantage of it that haven't been. Just as a heads up, when it comes to level instances, be aware that you can break any level instance into its initial parts. So if I got this level here and I drag it out to there, I can then just break it into all of the meshes that it has been made from, which is a great way to either reconfigure it into something similar but different, make another level instance, or sometimes, I might get my door level instance with all of its meshes and drop it in place, break it, and then start to destroy it to make the door that's been through some stuff in my level, So having that, very useful. The last point that I'm going to bring up on level instances is just level instance zoo. So level instance zoo is just, this isn't a feature, but it's just a workflow thing I want to flag. If you're making a bunch of level instances and you start going down that pathway, it's not a bad idea to have just one level with all of those things in there. It becomes much easier to like visualize what's going on and browse through. Now, I know PCG isn't an unfeatured feature. We have been featuring the heck out of that. But I wanted to bring it up because I wanted to flag some of the things that are in PCG that you should know about. For anyone that's unfamiliar with PCG, PCG is procedural content generation with Unreal. It came in 5.2. And it allows you to create really interesting procedural things based on stuff that you're doing in the world. First of those that I wanted to bring up ties back to my previous point, which is I can get a level instance, and level instances, when you modify them, can be saved as PCG data assets. And when you save out a level instance as a PCG data asset, what it actually does is allows PCG to look at that level, sample it, and then instance that level and all of its meshes a bunch of times. A cool thing with PCG is that it actually lets you not only sample that level a bunch of times, but you can grab tag data. So I can have inside of that sublevel, like keep it vertical, and PCG, like on all of my trees. And when PCG places this mesh all around the world, it'll then grab the trees from those levels that it's sampling and be like, all right, but we're going to add this to the world, but we're also going to make sure those trees are upright, or we're going to give a random 360 spin, or maybe anything tagged with clutter just has a 50% chance of not existing. So even though we're sampling an existing level, we're getting rid of half of the stuff that's in there. You get what I mean? So that workflow is really, really powerful, but like coupling PCG with level instances is done through PCG data assets. And I don't think people really caught how useful that was when the patch notes were like PCG data asset support. So I really wanted to flesh that one out for folks. Now, a few things in PCG to bring up. PCG does sample the landscape layer at any point, which means that in this case, I'm painting a landscape layer called rock. And as I do, PCG is kind of picking up the pace and saying, hey, I want to make sure that we're putting rocks on any landscape areas that have rock. This is a pretty cool approach because it means we can do some really interesting stuff using the landscape data as kind of like edit layer data that's filling in information about the world. And it means that there are plenty of situations now where we were previously using landscape grass that you should potentially consider using PCG for instead. Now, a few nodes I wanted to bring up on the PCG front. First off is we have subgraph support, and we now have a subgraph in there for discard points on irregular surface. Discarding points on the irregular surface means that whenever you do PCG spawning, you can actually see whether that point has any of its ends outside of the ground. And if it does have any of its ends outside of the ground, discard it. So in this case, we start by putting all the big ones down, and then we discard those if they don't work, and then we grab the ones that are slightly smaller, discard those if they don't work, and then the smallest ones, which allows us to be like, try and put all your big things down and fit in as many big things as we could, and then I go down in a cascading series. So really useful node, hasn't been getting much use because it is a subgraph, and often you actually need to set it up as a loop, which can catch some folks off guard. We now have spline water data. So again, PCG, if you're bringing it in, be aware that you can sample the water width, velocity, and depth through the spline metadata. This means that you can have some really interesting effects so that, hey, look, if the nearby stream is running quickly, start to place down little rocks that gives it the impression of like some rapids and things like that. If the nearby stream is running slowly, let's just chill it out and maybe have some trees still growing there. On the PCG front, hierarchical generation is huge, but it's kind of tucked away. Hierarchical generation is another feature that I'll be covering in tomorrow's PCG talk that I'm giving. But essentially what happens is you can grab any part of PCG and say, hey, I want this to only happen within 5 meters of me. Sorry, 500 Unreal units. Or if you want, you can say, I want this to happen within 20 meters of me or 50 meters of me, and it only runs the generation when you kind of get into those segments. This is really, really useful because you can do things like saying, hey, I want to make sure that, I want to use PCG for really good grass in my scene, because landscape grass only puts grass on the landscape, whereas PCG has the capacity to put grass on every little rock and all sorts of other things inside the world. It can grow moss and all that kind of stuff. But often you don't want to have all of the overhead of having all of those assets in there. You know, like I don't want to pre-save out every blade of grass for hopefully obvious reasons. So being able to use hierarchical gen is a great way of being like, look, give me all the trees and give me all the boulders, but only when we get close do I want you to, at runtime, figure out where the grass placement should be and do that in little grid cells. So really, really useful. At the moment, a system has to be set to runtime, so everything is runtime, and you just generate the trees at a mega distance. You can get around that by using PCG data to access other PCG systems that are static, so you're grabbing cache data and combining static with runtime. That said, I believe in the future we're looking at having the capacity to kind of mix and match the parts that are static versus the parts that are dynamic. On the PCG front, last little point I wanted to bring up was the biome plugin. So the biome plugin allows you to get the world and instead of getting one PCG graph for a forest and another PCG graph for the beach and putting them next to each other and hoping that they don't cause problems with each other, the biome plugin is really cool and allows you to run all of your graphs but off of the same seed of points that then has a level of fall off between them. So when I put my beach PCG next to my forest PCG, it actually merges them together a little bit, and you can get a little bit of fall off between the actors, which I think is really, really cool. There's a lot of situations where the biome plugin is handy. Now, on a personal level, the biome plugin is incredible, and that team has done a lot of work to get that going, and I'm really, really excited to see where it goes in the future. However, I know a lot of folks here have already started to build their own similar systems. So even if you're looking at this and you're a little disheartened and you're like, oh, I wish I had known about that, and you want to roll with your current system, just remember that it's all written in PCG. Like the biome plugin is just a bunch of really cool distractions and a bunch of really cool PCG systems that are layered on top of each other. So it's really easy to kind of open it up and even if you're not using the plugin directly, take some of the ideas and concepts from it and bring them into your own system. So even if you've already started to get your own beast of a system going to support your project, remember that you can still use it at least as a point of reference for things in the future. On the tool side of things, there's a couple of things I wanted to bring up. Interchange. The Interchange framework is something that we've got now. You can enable it. And it allows you to set up custom import and export frameworks. So this means that you can set up an importer that if you detect that they're importing something from the weapons folder, you can make sure that they get a custom little pop-up that says, you're importing a weapon, what is the blueprint you want this to be associated with, what animations are going in there, blah, blah, blah. And then it will go ahead and you can set up your rule sets so that when an artist brings in an asset, it's kind of doing that in a friendly way. Geometry script is a useful one. This has come in and it's been used pretty aggressively. So for the record, any of the modeling tools, almost any of the modeling tools can now be run through blueprint script. So in this case, I kind of created a quick procedural vine generator by just using the standard modeling tools to fill out my splines. But I want to point out that it works on other stuff too. Like you can use it for booleans, for instance. So I made a little fan, and wherever I put the fan, it grabs the mesh behind it, cuts a hole in it, and makes it so that that fan now has like it works without me having to micromanage that. And it's really not that much script to do it. It's a pretty clean process. But again, having these modeling tools just as things that you can kind of add extra stuff to is really handy. Scriptable tools mode is a thing that we've added. It's in the plugins. It's off by default, but it adds an additional mode. And that additional mode allows you to create click tools. It allows you to create drag tools. It allows you to create all sorts of fun stuff. But it kind of tucks them away in one nice place that you can create a bunch of tools for your projects without having to worry about custom setting up all of the input for that. It's just kind of pre-set up versions of the input, and you're kind of handling that extra development on top of it. Cool feature that came in with 5.4 is the Toolbox plugin. So the Toolbox plugin allows you to kind of drag in a bunch of just standard command lists. If you've got a bunch of stuff that's really by the numbers, like, hey, I want to set this console command, or hey, I want to open up this editor utility widget when I click this button, et cetera, et cetera. This is a really, really convenient way to just really easily set up your own little tool belts. Toolboxes. And that when you're in the editor, sorry, this was a longer example than I probably should have recorded. Ooh, I went too far. Spoilers, it was basically where I was. So what that means is when I go to here, Toolbox gives me a nice little pop out like this, which elegantly puts all of the little tools and buttons and things that I had into one little place, keeps it clean. And in this situation, there's a bunch of settings there to just change the camera lenses and things like that, you know? So Toolbox is a really, really handy thing if you feel like scriptable tools is like overkill for what you want, and really you just want to have quick buttons to execute console commands or things like that. It's great, you know, or whatever it is that you want to launch. But it's kind of an elegant system to house all them in one place. As far as bells and whistles are concerned, a few things that I want to bring up. First of those is that while, yes, there's features like motion matching, a lot of people are unfamiliar with the fact that we have the capacity to do animation analysis inside of blend spaces. Animation analysis looks at, like in this case, I've said, hey, look at the locomotion and check how fast the feet are moving. And when you check how fast the feet are moving, determine that as the X and the Y axes of my graph. And when you do that, I can just drag any animation in. And when you do, it'll automatically put them in the correct spots on the blend space. So this stops you from having to like eyeball the animation and be like, I think they're moving at 200 units per second. Instead, this is like, dude, they're moving at 212 units per second. You're like, oh, okay, I was close. MIDI sequence. So we have the Harmonix plugin. Harmonix plugin came in with 5.4. Very cool. It actually allows you to kind of set up little MIDI sequences inside of it. So when you set up little MIDI sequences inside of it, you can hear that, right? This is the easiest way to get carried away in a feature, and got a little ominous there. You can set as many like pages to this as you want, but a really cool feature is you can actually go back into your meta sounds and you can change the instruments that it's running. There's a bunch of just patches in there by default, so I can run that same thing as a piano, or I can run it again as, where are we? Upright bass. So cute little thing, and you can control all of like the MIDI sequencing there, like the speed or what have you, from like in-game variables. On the audio front, I also wanted to bring up just Soundscape. Soundscape allows you to set up procedural audio in your world where you can set up rule sets. You can say, hey, whenever we enter an environment with this kind of thing, I want to make sure that you've got whenever we go to an environment with this kind of thing, I want you to randomly spawn bird noises or bug noises or whatever else it would be around you. Okay? Really, really useful little feature that just stops you from having to hand place like thousands of sound effects inside your environment. I think it's really, really great. And it's based on gameplay tags, so you can have some pretty advanced stuff in there. Sorry, we're running short on time, so I'm speed running through this last couple. Data channels are an important feature that we've added that a lot of folks don't know about. Instead of spawning particle system after particle system after particle system here, data channels actually allow you to get Niagara and feed in information that says, hey, create another event within the existing particle system. This means that you're not spawning thousands of the particle system, you're just spawning one. It actually has a cool islanding mode set up that spawns one for every X number of units. So it automatically kind of breaks down the number that it needs to have into like grids within the world and figures out which one of them should actually be owning the particle system within it. There's some good docs online for this. Niagara sim stages are definitely one of the most slept on parts of Niagara. So while Niagara is often viewed as a particle editor, you can use it to run render targets. And those render targets can then be fed into everything else. And that's how Epic do really high quality fluid effects. It's how we do all sorts of really cool stuff. But things like this wind effect, I believe this was set up by Xiao Yue from the Chinese team. Things like this wind effect and stuff is actually reasonably easy to set up in Niagara, and Niagara can query physics events in the process. On the Niagara caching side of things, just be aware that any Niagara system you do, you can record. And when you do the recording, I'll jump forward, when you click the record button, it will play it in all of its like slow feedback because I put way too much stuff in there. But it means now that I can now play that effect back with complete consistency at any time. So Niagara caching allows me to play that back at any time with high quality. It actually can record variables in the system, which means you can still output like sim stage data and things like that. When it comes to other things on VFX side, I want to bring up the color picker. Just be aware that when you're using Unreal, everyone uses the color picker all the time, but you may not realize you have the ability to save themes. So you can be like, hey, these are all the colors for blue team, and these are all of the colors for red team. And the same color picker works through VFX. The same color picker works through like your materials, same color picker, works through everything, okay? Really, really powerful to just make sure you've got this set up, especially if you're tired of other people in the team using just the wrong red for the thing that you really wanted, a particular red. You know what I mean? They like, follow the rules. And you can set this up and commit the config of all of these colors to the team. Translucency overlay materials are a big feature. Translucency overlay materials are, I'll do a translucency pass on any object. Cool part of that, which I covered in my recent GDC demo, is that you can do things like I set up custom shadows here. By using the translucency pass, I can kind of derive what the shadows look like and then redo them, which is kind of a fun way to really quickly mess around with a bunch of different potential effects for characters and overlays and that kind of thing. We're almost at the end, just a couple left. Post-process material chain plugin came in 5.4. So this is really cool because you can run a post-process, but instead of outputting to the scene, you can actually output to a render target and then create another post-process that takes the previous post-process's render target as like post-process input 1 or post-process input 2 textures. So what I actually do here is, it's a little tricky to see, but I'm actually doing one pass which creates outlines, saves it, and then I'm doing another pass which gets my outline shader, and then I'm blurring them to kind of create some slightly cooler looking lines between the two. You know what I mean? So there's some really cool effects you can do from this, and I know a lot of people that are handling film and TV side of things especially would have great joy at knowing that that feature exists. The Slate post buffer is a really big one. So this allows you to actually render your scene with UMG into a texture, and then you continue the rest of the UI over the top. So in this situation, this is in the content examples for you to look at. It's actually rendering that scene down the bottom, but then it's applying all of the like VHS style footage to it after it's rendered it, which is a really cool setup to do. So being able to do that means you can create some really, really interesting UMG effects that you previously couldn't. It's much easier to put UMG things in the world with really, yeah, there's I don't know, we've seen some really kind of cute effects already starting to pop up here, and it helps UMG blend in with everything else. So I strongly recommend you look at that if you're touching UI at all. Console variables tool, I've brought up a lot of console variables, but be aware that you can go window, console variables, and you can actually search for any console variable with that thing from in here. You can see what the value currently is, and you can see if it's being overridden by you, a constructor, or whatever else. On the console variable side of things, we've got A/B test. Any console command that you've got, you can type in A/B test and then a console command and then 2 numbers, and it will automatically run that CVAR over and over and over again on loop to show you the difference between the two, and it will actually record the performance difference between the two and tell you the chance that that was due to noise versus the chance that that was due to actually changing the variable. And just remember, any CVAR that you add, you can do console, you can do a question mark after it to find out what's going to be going on with it. Just type in the console command, space question mark, and it'll tell you what that result of that is if you are trying to get through everything. Couple of things left. You can leverage the texture graph in there. This is still in the early days, but it is in there in 5.4 to start poking at. This is a graph setup that we have in there to kind of output final objects. So you can set up the scene and kind of blend through your graph to output textures that are custom set up. This is a really cool thing that I think is in its early days right now, but I am quite excited to see where it ends up in the future. So one of the last ones I want to bring up is Dataflow. On the when you are creating any destruction in your world, Dataflow has been added to the engine. Dataflow is really cool because it actually allows you to set up geometry collections in your world through a graph-based setup, which means that if you're trying to get destruction set up in your scene, but you have thousands and thousands of meshes, these don't need to be handled one by one. Instead, you can set up rule sets through Dataflow to kind of guide that, and it really cuts out a lot of work. The last 3 things that I want to bring up are the physics control component. Physics control component has been added to the engine for a little while now, but it really does mean a lot of your animations can have a lot more life in them. Being able to make sure that when you can actually shrink your collision cylinder with people, and when you touch a wall, you just get that little bit of a pushback from it and things like that. It really, really does add a lot to your scene. The cheat manager is another feature that's been in UE for quite a while that folks aren't taking advantage of. Just be aware that anything that you add into the cheat manager class that you set in your project allows you to add custom console commands very easily. So in this case, as long as I have that function and it's got that flagged over there, I can now type in add health and it will automatically execute the add health cheat function. Really, really, really handy for debugging. Blueprint C++ header overview. If you are moving your content from Blueprint to C++, just be aware that you can auto-generate what the header would be of the current thing, and that gives you a really good idea of either what to copy and paste or what that's kind of doing on a native level if you're trying to understand what some of the checkboxes and such are there. And finally, the very last little thing that I really wanted to bring up on this presentation is gameplay tags. So gameplay tags, most people that use the gameplay ability system know about them already. But even if you're not using the gameplay ability system, be aware that you can create tags like key.red, key.blue. But the important part that a lot of game designers who aren't using GAS don't know about is that you can set up any variable on an object. The variable is the query. So I can say this door opens if this variable is met. And the variable is, do they have the red key? Which means I don't need to have custom logic for have they got a red key and have they spoken to this person, have they been here, et cetera, et cetera. I can just throw tags onto people anytime I need them, and the variable can kind of store that information. When I said this was the last point, I lied. Sorry. This is the last point. And this is, if you've ever tried to do language passes, but you're someone like myself who is awkwardly only speaks English, but you'd still want to check that we have correct language support, you can launch your project with -leet, which is the most 90s console command that I think we have. But if you launch your project with -leet, it actually launches your game in leet speak on anywhere that there's meant to be, like anywhere that correct language setup has gone through. Instead of putting it into Spanish or German or whatever else, it actually just puts it into leet speak, which is conveniently still able to be read by anyone that grew up with MSN, while at the same time, it also means that you can see when there are gaps in there and you can still get through the project. It's kind of I find it really useful as a feature, despite being very funny to me. So anyway, I know there was a lot of stuff covered here. I went a little bit over time, sorry about that, but I hope this has been useful. I'm going to be giving a PCG talk tomorrow to cover some of the stuff there in more detail. But otherwise, if you see me around the show, say hi. I'd be happy to give you more detail on some of these features. Thank you very much and enjoy the rest of Unreal Fest. I'm sure this will be a blast.